So in this lesson, we're going to be testing the difference between two means. So we're assuming that when we're making a statement, either the means are equal or the means are different. Now, if they're equal, in theory, if you subtract the two, it should equal 0. The difference between the two should equal 0. If they're not equal, then there should be some difference, either a negative or positive difference, depending on how we subtract the two means. The method used is very similar to dealing with hypothesis testing for large and small sample size. But this time, the hypotheses are a little different because we are going to include two means in the statement. Let's take a look at the first example. It says the survey found the average rate of a hotel room in Niagara Falls is $88.42, and the average room rate in St. Catharines is $85.61. The data was obtained from two samples of 50 rooms each, and the standard deviations were $5.62 and $4.83 respectively. At alpha equals 0.05, can it be concluded that there's a significant difference in the rates between the two cities? Now, looking at this question, you can see that our average from each of the two cities is different, but the question is, when you factor in the standard deviation and the size of the samples, are they far enough apart to say that the rates are actually different? So the first thing we're going to do is we're going to state the hypotheses. So reading the question, you can see that there is no indication of direction. It doesn't say Niagara Falls is greater than the other. It's just saying there's a significant difference between the two. Alright, so as a result, we end up with the following then. For the null hypothesis, we're saying that the mean for Niagara Falls is equal to the mean for St. Catharines. The alternative hypothesis would then be the mean for Niagara Falls, does not equal the mean for St. Catharines. So just like before, we would write equality for the null hypothesis and the inequality for the alternative. Now, another way to look at this, and some texts might use this instead, is if we were to bring the mean over for St. Catharines, say, we would end up with the following. The mean for Niagara Falls minus the mean for St. Catharines equals 0. The mean for Niagara Falls minus the mean for St. Catharines does not equal 0. And that's what I was indicating, is that is the difference significant or not significant? Does it actually equal 0? If it does equal 0, that would mean that the two values are equal. If it doesn't equal 0, it means that one is far enough from the other when you factor in the standard deviation and sample size. So here's our first step then, our hypotheses. Second is to determine the critical values. Well, just like before, our alpha is 0.05, but it is a two-tail situation because it is saying equal to or not equal to. So that's a two-tail situation. So keeping that in mind, let's find out what the critical values are. So after drawing our normal curve, we know that's a two-tail situation. So there's our two tails. And the alpha was 0.05. Okay, so once again, this would really mean alpha over 2, which is 0.05 divided by 2. Okay, likewise. Okay, so for these questions, we will be using the z-score. So we're going to use z value to determine what the critical value is. And since the area of the tail is 0.025, that would make the area in the center 0.4750. Once again, we're going to go to the Z table and find out what value is associated with this middle area here. Okay, and some of you might know right offhand what that value is, but once again, let's just take a look at what this is. So go to the Z table, and we're looking for the area of 0.475. It actually is right there, and that's associated with a value of 1.96. 1.96. There we go. So we'll put 1.96 as the value here, and on the left hand side it's negative 1.96. So next we're going to calculate the test value, and the test score this time is slightly different. Okay, so the Z score this time, because we are combining two of the means, and we are then subtracting the means, what we would do is subtract the mean for Niagara Falls from the mean of St. Catharines, and then we're going to divide. Now in this case it's combined value, so it is the standard deviation for Niagara Falls all over the size of the sample for Niagara Falls. Now it turned out that they were both 50, so there's no reason to be concerned about order. And then we're going to add for St. Catharines over the sample size of St. Catharines. So you see the formula has changed a bit. Now there is one small detail that has to be added, and that is we actually square the standard deviation. In other words, these are your variances. Okay, you don't have to get too hung up with that. Just know that the formula is taking the standard deviation, squaring it, and then dividing by the square root of the sample size. Now if you were to cover, say, this part up here, you'll see that you would actually end up with standard deviation over square root of sample size, but we're doing a combination of the two, so that's what is taking place here. So based on our information, let's plug in what we know. And so when we plug in our values, we end up with $88.42 minus $85.61 all over 562 squared, standard deviation for Niagara Falls, divided by 50, because the sample size was 50 for both. Okay, and we're going to take the square root of that bottom. Okay, having said this, I'm going to ask you to pause the video and see what you come up with for your value for your Z score. Okay, I got the following. So the difference on top ends up being 2.81. And then the values for squaring 5.62 is 31.5844, and that's over 50, plus 23.3289, and that's over 50 as well. Now, common mistake, students forget to take the square root of that denominator, so it's 2.81 over, and I'm showing a lot of detail here. I just want to make sure that you know how to calculate that denominator. So that gives me 0.631688 plus 0.466578. which in the end gives us 2.81 divided by the square root of 1.098266. Let me move that up here so I don't run out of room in this page. That then gives us 2.81 divided by 1.04798,187. Once again, I stress that you do not round until the very end, because rounding at any point in these parts of the question will affect your denominator, which will affect your overall answer, which can give you the wrong outcome. So do not round until the very end. So 2.681,344,096. And now we can round finally 2 decimal places because we're using z-score, so it's 2.68 is our z-score. So since our z-score is 2.68, let's go plot that on our graph. And once again, I'll use my color here. And 2.68 works out to be out here. Okay, and our decision then is to reject. We then reject the null hypothesis. Right, so 4 is the decision, so we reject H naught. And 5th is to say, well, what is it that we found then in the end? Well, since we are rejecting H naught, and in other words, we are not rejecting the alternative, there is enough evidence to say that there is a significant difference between the two means between Niagara Falls and St. Catharines. Alright, so let me state that then. So our final conclusion then is our sample data indicates there is a significant difference in the population means. We can cut that off right there, but I'm just saying, well, what do those means represent? Well, they're the room rates between Niagara Falls and St. Catharines. Now you have to see or agree that the process is the same as doing large sample size and small sample size for hypothesis testing of the mean. So the only thing you have to be careful with is just making sure that when you're calculating the z-score, that we just paid attention to the detail and make sure that the variance is lined up with the correct sample size. Okay, so you have to read the questions carefully to make sure that you're dividing by the proper sample size for each of these two parts. Otherwise, everything else should be pretty straightforward. I'll move on to the next example in the next video, that is.